Section 2.7 is titled Modeling with Quadratics. Okay. Question we're trying to answer today is how can you use a quadratic function to model, here we go, real life situations. Okay. So we have some goals to answer that question. How do you use a quadratic to model real life situations? Somebody volunteer to read my first goal today. Volunteer first goal.
Write equations of quadratic functions using vertices, points, and x-intercepts.
So we're going to use some vertices. Vertices is just plural for vertex. Points and x-intercepts. You want the second one, Annika?
Write quadratic equations to model data sets.
Okay. And we're going to do some Google searching today. We're going to see if we can't find ourselves. Remember when we did linear regression? You plugged all those points in the calculator and then it threw out a line for you. Remember doing that earlier this year? Okay. Well, we're going to do the same thing. You're going to have a collection of points, but instead of calling it linear regression, it's going to be called a, what family of functions are we working with again? It's going to be, well, no, what family? Quadratics. We're going to be looking at quadratic regression today and show you how that works. So this is really a pretty cool section. So what you might want to do today, you might need a calculator today. You might not. If your phone is your calculator, be careful. Okay? Just be careful. All right. Average rates of change. First vocab word up here. Average rate of change. If you ever see this phrase, average rate of change is the one word I want you to see or seek out. What is it, kids? Slope between 2 points. Okay. Anybody recall that goofy formula for slope?
Rise over rise?
That's the definition of it. When we start putting things in point form like this, or the slope or the average rate of change between 2 points, slope can be defined as y or m equals y2 minus over. It's really a change in y over change in x. Change in y being your rise, change in x being your run. So we've looked at stuff like that earlier this year. So recall slope formula right there. Second y value or second point y value minus first point y value over second x value minus first x value. Okay? We're going to talk about first differences. If I say, hey, what's the difference between 10 and 4? What are you going to tell me? 6. So difference meaning what operation?
Subtraction.
Mm-hmm. You guys got this down. Yep. It's first differences. What's this say, kids? Linear data have constant first differences, all right? And I'll show you what that means here in a second. Okay, first differences. It just means the difference or subtraction, one number minus the other. Second differences. What's this say? What's this say?
Quadratics data have constant second.
And I'll show you what that means here in a little bit. But, guys, what power are all quadratics raised to all the time? Yeah, second power. So this idea that quadratics have a constant second difference is all related to the parent function of a quadratic being to the, which power? Second power. Okay? So we'll talk about that. I'll show you what that means here. Guys, we've done this before. We need to recall a system of 3 linear equations. Remember this right here? How many equations? 3 equations with? I think when we took the quiz last time, those were your favorite type of problems to work on. Is that right? Humor me and say yes. Jaden, lay on your side and do that, okay? Okay? All right, and then quadratic formula. You guys have done the quadratic formula before. It's a way of solving quadratic equations. Anybody remember the quadratic formula? Okay, I think I'm going to try and repeat you. The opposite of b plus or minus the square root of b squared minus 4ac all over what? I want everybody to put their hands together for Mr. Rhett. That was good. That away. Good job, Rhett. Yeah, and this only works when you have a quadratic in standard form. And it only works when you have ax squared plus bx plus c. And it must equal what here, kids? 0. Okay. All right. Looks like a donut hole, but okay. It looks like Chase Elliott's burnout yesterday after he won the race. So that was good too. Chase Elliott won the race yesterday. NASCAR. Them there cars go around that track real fast there. You know what I'm them there talking about? Yeehaw! I love my NASCAR. In fact, I just ordered tickets to go back to Michigan again next year. Fun stuff. All right, anytime you're using quadratic formula, you have to make sure that your formula or your function is equal to what value, kids? 0, okay? So if they say find the roots, you assume that your function is going to equal 0, and then we're going to use this formula to solve. We'll use that in a little bit, okay? All right, let's get started here, guys. First example that we're asked to do. It says, example 1 up here. We're going to write an equation using a what and a what, kids? Using what and a what? Okay. Vertex and a point. So I want to start this right here. First of all, it says if you're going to write an equation using a, I'm going to underline this word, vertex right here. I want you to think about this. There's 3 different forms we've kind of talked about with functions. Okay? One of them is vertex form. One of them is standard form, and one of them is x-intercept form. For quadratics, there's 3 different types. Okay? The idea that we're saying, hey, I'm going to tell you what the vertex is here and then give you a point. Boy, vertex form, standard form, x-intercept form. What form do you think we should probably choose here? What are they giving you up here? What did I underline? What word did I underline? This is a giveaway right here to use what form? This is a giveaway, a dead giveaway to use vertex form. Okay? So here's how this works. If they say, hey, here's your vertex for any quadratic, and you have to write a model for this right here, this is the way you're going to do this, and this is how it's going to work best. First of all, general form of vertex form takes on the following form. Y equals some value A times x minus h squared plus k, where the point h comma k represents your vertex. Okay? So what you're asked to do here, guys, is write an equation that would go through these points. Be a vertex at 25, 30, and then pass through a point 0, what? So write a quadratic function with the vertex 25, 30, and passing through which point, kids?
0.
All right, here's how this works. Anytime you're using vertex form, your job is to find values for A, H, and K right here. All right? Anytime you have to write a function in vertex form, your job is to find a value for A, H, and K to complete this. Well, guys, do you know what the vertex is right off the bat? Okay, the vertex is, careful on that, 25, 30. Okay? So this is kind of like my h, k value here. So in for h, what am I going to plug in?
25.
And what are you plugging in for k, kids?
30.
Okay, so the first thing you're going to do is you're going to call this y equals some value a that we do not know yet times x minus, what's the h value?
25.
25, because that's where the vertex is. And then the k value, kids. What's the k value?
30.
All right. What 2 values have I established up there of the 3 already? Which 2 values have we established already?
H, K,
Now we need to find what?
A.
All right, here's the deal. They said, you know what? Plug your vertex in first for h and k. But then they go out there and say, oh, by the way, this graph is also going to pass through another point. That point being what? What point does that pass through? Other than your vertex.
0, 20.
Okay, here's how this works. What this is saying, in this function, this is simply saying that we have to pass through a point that says when my x value is 0, what's the y value, kids? What's the y value? When x is 0 in this parabola, what's the y value? 20. Okay? So after I've plugged my vertex in for the variables h and k, your job simply is to put in 0, 20 for x and y. That's going to allow us to solve for what, kids? So let's do that. I'm going to move my work up to here. Okay, we're going to plug into point 0, 20. We're going to plug into point 0, 20 from here, which again says that when your x value is ever 0, y has to be what? Y would have to be 20. All right, so let's do this. In for y, right where I'm at here, what are you going to plug in? 20. Do we know what the a value is yet, kids? We don't know the a value, right? Guys, if I'm plugging 20 in for y, what are they telling you to plug in for x now?
0.
0. You bet. Whew. What's 0 minus 25 in parentheses, kids? Negative 25. Somebody take negative 25 times negative 25 now and square that for me. Negative 25 times negative 25. Do you get 625 when you do that? You guys all agree in this parenthesis set right here, it's negative 25, right? Okay, what's negative 25 times negative 25? Because I have to square it. 625. So that's 625 times which variable is still out in front, kids? So this is going to equal 625a plus 30. Again, kids, the reason for plugging x and y in is because we need to figure out how many of these variables over here. How many are highlighted? 3. We were easily able to plug into vertex, but I'm plugging now a point in for x and y to help us solve for a. To solve for a, what would be your next step here, kiddos? Subtract how much? So I've got negative 10 on the left equals 625a. Whew, this is getting kind of tricky. I'm going to make some room here quickly. Give me a second.
Why did you subtract 20?
Subtracted 30 actually. Because I'm trying to get a alone. We're trying to figure out our value for a right here. Okay, now what am I going to divide by, kids? What are you going to divide by to get a alone?
Negative 10.
When did you divide by 625, right? Okay, now I'm going to leave this in fraction form here, and I'll tell you why here. The 625s will cancel. Help me out, kids. Do you agree that 5 will go into both negative 10 and 625? You agree 5 goes into both of those? Okay, I'm going to call this, I'll just tell you real quickly. When you simplify these by 5, you get negative 2 over 125 equal to your a value. Okay. Now I'm going to show you something here in a second, but I'm going to write this full equation out. Okay. The first thing we did is plugged in our vertex values for h and k. Then I plugged in x and y after we plugged those in. Plugging x and y in allowed you to solve for which variable, kids? What did we just solve for here? Okay, so your final equation is going to look like the following here. This quadratic that has a vertex at 25, 30 and passes through the point 0, 20 is now going to be y equals, what's the a value, kids? What's the a value? And again, that came from this negative 10 over 625. I just divided both the numerator and denominator by 5 because I knew I would simplify that. Times x minus 25 squared plus 30. Right? Do I have a value in for A? Do I have a value for K and H? Okay? That's your quadratic. Now I want to go over here quickly and show you if I'm right.
Okay, so what's the equation, the purple one?
The purple one would be what would be your final answer, yep. And again, why did I choose vertex form here, kids? It gave it to you. It gives you the vertex. If they're going to give you the vertex, it kind of makes sense to use vertex form, right? You're not going to try and fit, you know, square pegs in a round hole, are you? You know that game that we talk about? You ever talked about that game? You ever heard that saying? You guys are trying to fit square pegs into a round hole? You ever heard that saying before? Never heard that? You'll grow older. You'll hear about it someday. I'm going to run into decimals real quickly. Anybody need more time getting that part down? Okay, let's do this. I want to change my window a little bit. First of all, tell me what we came up with for a function here, kids. Y equals what? Was it negative 2 over 125, kids? All right, now I don't remember the other part. So what's in parentheses? X minus how much?
25.
And that was all to the second power. Shoot, I screwed that up. What was the K value out there on the end?
30.
Okay, I want to do something here quickly. Let me change my window on this. All right, take a look at our graph here, kids. Does it appear the vertex is kind of right up here? Okay, let's find out what that vertex is. What's it appear to be? Ooh, did that match what we wanted the vertex to be? You guys okay with that? Okay, what point did we have to pass through? In that exercise, what did we have to pass through?
0, comma.
Did we pass through 0, 20? Now, isn't there one more part to that question, kids? Isn't there one more part to that question, example 1? What's it say there? Evaluate when?
X equals 60.
Okay, I can tell you right here graphically. Now, if I follow over to 60, looks like to me that, what's it say? What are you going to get when you get over to x equals 60?
Y equals 10.4.
Y equals 10.4. Let's just see if that's true. Okay, let's just see if that's true. I think it is, but I'm naive. So, if I wanted to know what's y equal when x is what value again, kids? What's the question say down there? Evaluate when x is equal to?
60.
Yep, after I've written a function. So, here we go. Let's just put in x equals 60, the last part of this. You'd have y equals negative 2 over 125. What are you plugging in for x, kids? 60 minus 25. Who has a calculator out for me right now? Whoever has one, say I do. Nobody has a calculator.
I do.
Okay. Who's willing to punch this mess up for me? Somebody go 35 squared for me first.
1225.
Okay, 1,225. Now let's multiply this times negative 2. Take that answer times negative 2.
Negative 2450.
Okay, now divide by the 125.
Negative 19.6.
And now add the 30 on the end.
10.4.
10.4. So when x is equal to 60, on that question, when x equals 60, y is equal to 10.4. Lot going on there. Again, the biggie. Why did I choose vertex form? Yeah, I mean, they said, hey, you're in Vertex. There's a Vertex, so let's use Vertex Form with that, right? Okay. What three values do you have to find if you choose Vertex Form as your start, kids? What three values do we plug in for? A, H, and K. Very good, guys. Very good. All right. That's pretty upper level stuff. Let's see if we can't move on to this next page then and see where we're at. Example number 2 up top. How about a volunteer to read this for me? Volunteer to read example 2 for me.
The meteorologist creates a parabola to predict the temperature the day after tomorrow, where X is the number of hours after midnight and Y is the temperature in degrees Celsius. The points used in the model are 0, 6.3, 6, 0, and 21.
Meteorologist isn't too popular around here right now, is he? All this darn rain. My goodness.
It's supposed to rain Thursday?
No, I think it's actually supposed to be kind of cool and sunny. Shocker. But we'll probably get so much rain this week that it'll be too wet to run anyway. You know how that goes, right, Jaden?
Yeah. Will they reschedule that?
That one would get rescheduled, yes, because it's conference. Let's kind of make a visual of what's going on here, kids. This is an interesting one. Again, I'm going to write down up top. We have 3 forms to use. We can use Vertex Form. We can use Standard Form. Or we can use X-Intercept Form. In X-Intercept Form, we haven't talked about much, but, you know, X-Intercept Form is going to happen when you have an X-Intercept, okay? The one that works best, preferably when you have 2 X-intercepts. Okay, so what were the 3 points that this meteorologist was using to make a prediction about tomorrow's temperature? Which was the first point, kids?
0,
6.3. That's this point right here. Next one.
6, 0.
Ooh. What's the next one?
21, 0.
Oh. Oh my goodness. Wouldn't you just know it would happen that way? We have 2 points that fell where?
X.
On the x-axis. We have 2 x-intercepts, don't we? Isn't that awesome?
No.
You guys don't share my enthusiasm about this? Well, here's the deal. If you have 2 x-intercepts, might be a good idea to use which of these 3 forms to start this, kids? We're going to use X-intercept form, okay? So, boy, oh boy, I'm going to write this down. Since we have 2 x-intercepts, I think it would be a great idea to use X-intercept form. Excellent, kids. Excellent. All right. X-intercept form. Here it is. Y equals some value A times X minus P times X minus Q. I'll make a note right here. P and Q represent the X-intercept value. Okay? Anybody want to guess what 3 variables we need to plug in for to make this work? Vertex form was A, H, and K. Anybody have a guess what we're looking for X-intercept form?
A, P, and Q.
We need to know A, P, and Q. Excellent, Sterling. Good job. Well, P and Q represent what again, kids?
X-intercept.
Do we know the X-intercepts? Do we know the X-intercepts here?
Yes.
What and what?
6, 0, and 21.
So 6 is the X value on the X-intercept. What's the X value here?
21.
Yeah, the X-intercepts are 6 and 21. 6 and 21 represent P and Q. So, here we go. This becomes Y equals some value A. We don't know that yet. Times X minus 6 times X minus 21. Now, kids, this graph looks like it kind of comes down like so, runs through the points, and probably comes back up like that. So help me out with this. Think A is going to be a positive or a negative value or what? I don't know. Is that a U shape or an arch? U shape or an arch? Looks like a U. Okay, so am I going to have a minimum value? Well, if it's a U shape, that one means that A is going to be some kind of a positive value. Okay? Is there another point up there that we know that we're not paying attention to? Kids, is there another point up there that we haven't paid attention to yet? Okay, we got to figure out what A is, but look at my graph. Isn't there another point we haven't paid attention to yet?
0,
Yeah, 0,6.3. We're going to use that other point right here now to plug in for x and y, because plugging that other point in is going to allow us to solve for which other variable, kids? BA right there. All right, so give me this chance to do this quickly. Make some room. Different color. Here we go. I'm going to use the point 0,6.3, which states when x is 0, your y value is 6.3. Here we go. Use that point to plug in. What are you throwing in for y, kids? 6.3 equals your a value times. What's the x value when y is 6.3, kids? 0 minus 6. And then 0 minus 21. I'm no mathematician, but I think, whoops, I can't even get the right numbers. I think this is a equals negative 6 and negative 21. Oh, somebody negative 6 times negative 21 for me, please. So this is 6.3 equals 126 A. How are you going to solve for A, kids? How are you going to solve for A? Divide by 126. So A is going to equal, boy, help me with my math. 6.3 divided by 126. Is that 0.05, kids? .03 divided 126. Is that 0.05? Who's running that for me? 6.3 divided 125. I don't care if your phone's out now. You're just on the calculator.
It is.
Okay. All right. I'm going to jump down to part A. Part A says write a function f that models the temperature over time. To write this function, we said use what form, kids? Okay. We needed to say, if we're using x-intercept form, we need to be able to plug in for A, P, and Q. Here's our function in part A. Y is going to equal the A value, which we just found to be 0.05. Times x minus the P value, which was 6 times x minus 21. Okay? Now, in part A, they go on to say, after you've written that function, they say, what's the second sentence say in part A? What is the coldest temperature? Okay? You guys agree the coldest temperature would be like a minimum? Isn't a minimum from this graph that we've started right here going to kind of be right between these x-intercepts that mirror each other? Would you agree with that? Guys, if I have an x-intercept at 6 and an x-intercept at 21, how are you going to find the very middle of this right here, kids? How are you going to find the very middle of 6 and 21? Average, you bet. So 6 and 21 add up to 27. Average is going to happen right here at 13.5. Okay? So right here, we know that this minimum value is going to occur. This minimum value right here on this graph is going to occur when x equals 13.5. So they're saying the coldest Y value, or the minimum value, coldest temperature in this case, is going to occur when X is 13.5. X is going to be the number of days or the number of hours after midnight. I'm sorry. Okay? So we're going to evaluate this when X is what value, kids? All right, let's roll. By the way, does this temperature look like a negative temperature or a positive temperature given our graph? Negative. It's below the x-axis. Let's see. What are we plugging in for X to find the coldest temperature? Coldest. What are we plugging in?
13.
That's where the minimum is going to occur. It's going to occur around that line of symmetry, found from the average of the x-intercepts, like Rhett stated. All right, who has a calculator handy for me right now? Anyone have a calculator handy for me? Whoops.
I do.
Okay, I need someone to do, gosh dang it. I need someone to do 13.5 minus 6 for me.
7.5.
So this becomes 0.05 times 7.5. And then I need you to do 13.5 minus 21.
13.5 minus 21.
Yep. I think that's negative.
Negative 7.5.
Okay, so here's what I need, kids. I need you guys then to find this value for me by taking 0.05 times 7.5 times negative 7.5.
It's negative 2.8125.
Negative 2.8125. So y is approximately negative 2.8 degrees. The coldest temperature is approximately negative 2.8 degrees in what, kids? How'd they measure it up here? Celsius. Very good. Okay. Celsius. Wow. Amazing. Last part B, we'll stop here. It says, what is the average rate of change on the interval which the temperature is decreasing? Okay. At time 0 or at midnight, what was the temperature, kids? 6.3. How many hours did it take to get to the minimum temperature, kids?
13.5.
Okay, and at 13.5 and a half hours after midnight, what was that temperature? So they want to know, what's the hourly average rate of change in the temperature? Meaning, how much does my temperature drop every single hour from the start of this problem? What they really want to know is the slope from your start time, point 1, which was 0, 6.3. What would be the point for your coldest temperature in this? What, comma, what? Where did that minimum value occur on that quadratic model that we just formed? What was the x value down here for that minimum point? And it went all the way down to what? So we want to find basically the slope between these two. When we at midnight, whatever it was, midnight, temperature was 6.3 degrees Celsius. Over time, it got to a minimum, negative 2.8 degrees Celsius. That took 13 and a half hours to happen. They want to know how quickly did the temperature drop every hour. We're just finding the slope of this. Here we go. Your slope in this is simply, what's the y2 value? Negative 2.8 minus your y1 value, which is
6.3.
over x2 minus x1, 13.5 minus 0. Okay? Now, this turns out to be, oh gosh, negative 9.1 divided by 13.5. Somebody run that for me. Negative 9.1 divided 13.5. We'll go two places. Negative 9.1 divided by 13.5.
Negative 0.67.
So it means that this dropped negative 0.67 degrees Celsius per hour. Every hour the temperature went down negative 0.67 degrees until it got to its very minimum. Right? I think that's a great place to stop. We have basically 2 more examples to look at. Tomorrow I'll get you started on some things with this. Wednesday's kind of looking like a data review for a quiz. And maybe a test. I don't know how this is all going to work. Okay, but I'm kind of leaning at your chapter test being on Friday this week, okay? Make sense to everybody? Any questions for me at all? You guys have a great Monday, okay? Hey, don't forget, if you didn't turn in 2.6 today, make sure I get it by tomorrow. Thanks, Lexi Wagner. Lex, again, I'll try and have that in my 4th hour for you, okay? Redskins are going to win today.
Reese is gonna have the most passing yards.
What have I done to myself today?
I had a Sour Patch cookie.
What's that?
I had a Sour Patch cookie.
No.
Yeah.
Are they good?
Grandma made them for Christmas last year.
Really?
Yeah.
Never heard of such a thing.
Like a sugar cookie and they're like inside.
Is it?
Yeah, it's good.
My defense lost 8 points for 1 touchdown.
My email.
Bears defense.
I wish I would have gave my Thomas a chance to win.
She said, sure.
What do you guys score?
I don't know.
20-something? 20-something? And
We're gonna do a lot of
you guys are
stuff.
close to 0?
Yeah.
It is a possibility, but well,
I mean, your team's supposed to get hurt.
I know, it's just really bad.
Alex Smith hit 35 points.
Watch Michael Thomas talk about getting points. That would be so good.
And I was thinking about that already.
If Trey would have started a running back, it would beat Doug. And if he would have started a tight end last week, it would beat Trey.
I think Michael Thomas needs like 26 points. I mean, Michael Thomas.
Like my nails when I get them done. Yeah, I might just go from here. Like I really liked it when I just go my nail polish off. Yeah.
No. We were just talking about if we were done. See, I gave my stuffy nose too. I feel like I'm definitely having a allergic reaction. Whenever I have one.
Have a good day.
You too.